Hello everyone, this is Thiago Alves. I'm the CEO at Autonomy and creator of the OpenPLC project. On today's video, we're going to talk about a new device made by Synergy Logic, the SL-RP4. This device, despite its size, it's a powerful edge computer based on the Raspberry Pi 4. Thanks to its aluminum case, the SL-RP4 can run without CPU throttling and maintain its core temperature, even on an ambient temperature of up to 50 degrees Celsius. The SL-RP4 can be used as an edge computer to collect data, as a gateway, or even as a PLC. It comes with OpenPLC pre-installed and configured, ready to be used. On the bottom, it has a rotary switch that can be used to read configurations or parameters in your program. This rotary switch can be read using the rotary switch block on OpenPLC editor. Using the OpenPLC runtime, you can add multiple slave devices to the SL-RP4 to control remote IOs. For our example video, I'm going to pair it up with a P1AM system from Automation Direct. We're going to use the OpenPLC editor to set the P1AM as a generic Modbus slave device, and then link it with the SL-RP4 using the slave devices module. Then we're going to upload a sample traffic lights program to the SL-RP4 and make it control the P1AM as a remote I/O device. Before we start programming our system, we first need to wire it up. So I'm going to start with the SL-RP4, power supply on the top, 24 volts, Ethernet cable on the bottom, and then I can attach it to my DIN rail. I'll do the same thing with the P1AM. Ethernet cable, programming cable, because I also need to program it, and power supply, 24 volts on the bottom. Attach it to my DIN rail. I'm ready to program my system.
Alright, now that everything is wired up and connected, the first thing I'm going to do is configure the slave device. To configure the slave device, I'm going to open up OpenPLC editor. And because I mentioned that this slave device is not actually a dumb slave device, it's actually a full-blown PLC, we'll have to upload a program to it and make it act as a dumb slave device. I created such project here. It's very simple. And the idea is, first I initialize all the modules. This is a P1AM, so it requires the P1AM in it. And then I have this P1 16CDR block. I only have one module connected to the CPU. This module has 8 digital inputs and 8 digital outputs, right? So it's perfect for our example. And on this program, I created 8 input variables and 8 output variables. They're all located at Modbus address locations, right? So I'm wiring up all these variables to the inputs and outputs of this module. So essentially what it means is that when this device is addressed over Modbus for this particular location, I'm actually addressing that particular output on the module itself, right? Same thing goes for the inputs. When you're reading inputs over Modbus, for that location, you're actually reading the input of the module, right? Very simple, just this. The program doesn't have anything else besides this. No logic, so it's not actually running any command or logic here. It's just acting as a dumb Modbus slave device, right? So now we're going to upload that to our P1AM. So we have P1AM here. This is the installed version. This is the COM port. Everything is correct. Now, one thing is worth mentioning. The default configuration for P1AM, it has some GPIO pins that you can use. Those pins are on the left side of the P1AM CPU. We're not going to use those, and in fact, I'm going to remove this so that OpenPLC will not control those pins. I want it to be removed so it won't conflict with my Modbus locations that are actually tied up to the external 16CDR module, right? And then I'm going to enable Modbus TCP on Ethernet. This is the IP address and gateway. All the IP configuration is correct. So I'm good to go. Just transfer it to the PLC now. All right. Now that the program has been uploaded, we're going to test it before connecting it to the SL-RP4. We're going to test it with Radzio Modbus. I have a Windows machine here running Radzio Modbus, And this is a very simple program to just connect over to Modbus devices. So I'm going to go here and hit connection settings to make sure that I have the right configuration. I'm connecting over Modbus TCP, and that's the correct IP address of the slave device I just programmed. So I'm going to create a new data sheet here, and I'm selecting coil status, so I want to know the status of the outputs, and I'll just hit connection connect. So I'm reading the status of the outputs. They're all turned off, and apparently everything is working just fine. If I go here and click on to change the state of an output, there you go. You hear the relay clicking. So it means that I am controlling these outputs. It's working as a Modbus slave device, right? Everything is as it should be. Okay, I'll disconnect then. Our slave device is ready to be attached to the SLRP4. Now, to attach a slave device to SLRP4, the first thing we have to do is to actually get into the OpenPLC dashboard. So the SLRP4 comes pre-configured with OpenPLC runtime. Everything is running and ready to go. I just need to open my browser here. I'm going to open Google Chrome, and the default host name, once you connect it to your network, the default host name for the SLRP4 is SL-RP4. You can access it typing just slrp4.local at port 88 on your browser. When you hit that, you're gonna be greeted with the OpenPLC login screen. The default credentials are OpenPLC, just like always. You log in, and now it comes running a test program. It's called the SLRP4 rotary test. The SLRP4, as I showed you, has this little rotary switch on the back that allows you, to program anything with it. You can turn it around to have like specific configurations. So maybe you have a program that has different setups, and depending on which where the knob is pointed to, it will run different configurations of that program, right? So this simple program, it's basically just reading that rotary switch and displaying here the position of the rotary switch here. It's very simple. I can even show to you guys what that program looks like. It's right here on the rotary switch. I will save this, and all it does is just creating this 1 second blinky output, and every time this thing is true, it will just call this rotary switch block to read the state of the rotary switch, report if there is any error, and if there isn't, it will just output the value of that rotary switch to my rotary variable that is located at the first holding register Modbus location, right? Here. So you can find this block here on add block under the SLRP4 category, and that's what it does. There's a little explanation about how the block works. So you can add this block to all your SLRP4 programs if you want to use the rotary switch that comes with it. All right, so now we see that everything is working. We can go back to our Google Chrome, and the first thing I'm actually going to do once I logged in is to change the username and password, because that comes with the default username and password, and I don't like that. So I'm just gonna hit users and click on the OpenPLC user, and I'm gonna change the username from OpenPLC to something else. Just for the sake of the demonstration here, I'll change it to OpenPLC demo, right? And change the password as well to something else. And once I save changes, it will go back to the login screen, and I'll have to log in again using my new credentials. Okay, now I'm back and I'm protected because I've changed the default username and password. The next step is to also change the host name. It comes by default with the SLRP4, and you can reach that just by typing the host name .local at port 8080. But if you have more than one SLRP4 device in your network, this will cause a conflict. So ideally, you should change this host name to whatever you want, as long as this is a unique name for each one of the SLRP4 units you have. So also for the sake of demonstration, I'm going to change this hostname to OpenPLC demo. All right, I'll keep everything else the same. I'll just hit save changes here. Now, when I'm changing the host name, this requires a power cycle for my SLRP4. So I will just stop the PLC here just to make sure that nothing is running, and I will power cycle it. It might take a little bit to boot up again, and once it boots up, I won't be able to access it on the SLRP4 anymore. I'll have to type in the OpenPLC demo to get there. Already have that ready. Some browsers require you to put the HTTP before the name. Might be ready to go. Let's see. Some networks will take a little bit longer to find the device. There you go. My network was able to find it, and I'm now connected to the new host name, right? I need to log in using my new credentials, and now my SLRP4 is fully configured, right? I have my own user and I have my own host name. Okay, now I'm ready to roll and put this device to test. So since we're using the SLRP4 as a PLC, connecting it to another slave device and controlling its IOs, you'll have to go here to the slave devices menu. On the slave devices menu, you can add new slave devices. You can add as many as you want. Those devices can be talking Modbus TCP over the network, or could be also Modbus RTU over any serial connection, right? For this example, I'm going to add a Modbus TCP device, that's the P1AM, running as a slave device. So I'm just going to call it P1AM. And as a template, I'm going to put a generic Modbus TCP device, right? I know that the slave ID for this device is 1, and the IP address is 192.168.1.195. Port is 502. And then for all the addresses, they all start at address 0. And for inputs, this slave device is configured to have 8 inputs, 8 outputs, and nothing else, right? As we did on our sample program. I'm just gonna save this, and now this device is listed here. The device has its own address for the SLRP4. So when you're writing SLRP4 programs, if you wanna hit, the digital inputs of the external slave device, you're gonna use these addresses, ix100.0 to ix100.7. If you need digital outputs, you're gonna use these addresses, qx100.0 to qx100.7. So it's already listed in here, okay? So we're good to go. Now we can go back to our OpenPLC editor and create a program for this thing. So let me just open it up here. And right now I have the rotary example. I'm gonna close this. I created another example project for this SLRP4 demo. So this is a little traffic light example. The way it works is very simple. I have a 1 second pulse configured here using these timers. So it's pulsing every second, right? And I have variables here configured to tell me how long I want the red, the yellow, and the green to run for. So I have the red running for 4 seconds, and the yellow for 1 second, and the green for 3 seconds. So I have a cyclic thing happening here. Every 8 seconds, it starts over. So to make it happen, all I did was to add all the 3 times together to have my total cycle. And using this total cycle, I created a counter, right? This blink pulse, 1 second pulse, is hitting my counter, and the counter is counting up to the total cycle amount. Once it reaches the total cycle amount, it will reset itself, right? And it will also hold the current count value here in this current cycle count variable, right? So I can use this to compare against, different values and know if I need to turn on the red or the yellow or the green light. So this is what I'm doing here. On the green light on, I'm comparing my current cycle count with the green seconds, and I know that it must be on for 3 seconds here. That's the default value here. So if it's less than 3, you should turn on the green light. Very simple. For the yellow light, I'm just adding the green and yellow together because, you know, I'm turning yellow after the green, right? So if the current cycle count is less than 4, adding these two together, and I'm not on the green light state, then I should turn on the yellow light. Finally, the red light is the easiest. If I'm not on yellow or not on green, then I should turn on the red light, right? Very simple. So let's simulate this program before we have it going to our SLRP4. I'm gonna start simulation here, and I will display in full screen so you can see it better. So this is what I was talking about. You see this 1 second pulse going, you know, every second, and then I have my full cycle calculated here. It's 8 seconds total, and then the blink is pulsing on my counter, and the counter is going up. It resets at 8 and starts over, right? And then it's comparing here if it should turn on the green, the yellow, or the red light, right? It stays 3 seconds in the green, then yellow for 1 second, and red light for 4 seconds, and then it starts over, right? Very simple. Apparently everything is working just fine. So let's upload this to our SLRP4. Because this thing is running on a Raspberry Pi based system, you know, it's the Linux runtime, we'll have to program it using the generated program on the editor. Right, so I click this arrow, and I can save it in a folder. I'm just gonna replace the traffic lights that I had previously saved, and that's going to generate an ST file for me, right? I can use then this ST file to upload it to my SLRP4. One thing I didn't mention though is the addresses for my red, yellow, and green light. If you scroll over here through my variables, you'll see here that the green light is the first digital output of my slave device, and the yellow light is the second, and the red light is the third. So these three are my outputs, these are their addresses, and if you compare it with the slave device addressing here, you will see that it matches, right? So that's very important for you to map the addresses correctly, otherwise you wouldn't be addressing this slave device and your program apparently would not work, all right? Now I'm ready to upload it to the SLRP4. It logged me out due to timeout. Let me log in again. All right. So I will go to Programs, and I will choose another file, and I'll go over to PLC Programs, Traffic Lights, example, Traffic Lights, there it is. So I'm just going to upload this file over here. I'm calling it Traffic Lights version 1.0, right? And this is just a little traffic light example for the SLRP4. All right, upload that. And done. Can go back to the dashboard, and I can start the PLC now. I can see that once I start it, it has connected successfully to my Modbus device, the P1AM, right? And everything apparently is working just fine. I can hit monitoring, and I can see that the program is running, right? And at the same time, if I compare, I can see that my P1AM is also toggling these outputs according to my program. They are in sync.
And the nice thing about it is that the SLRP4 is fully controlling the P1AM system. Even though this thing is a full-blown PLC, it's acting only as a remote slave device. For example, if I remove the Ethernet cable from the P1AM, it stops right there because it's not receiving any more commands. If I return the cable to the P1AM, it will resume the program and then continue running.
So now that you've seen the Raspberry Pi 4 working, you can go ahead and purchase yours at the Autonomy Logic store. Just go to the Autonomy Logic website and hit the store menu, and then you can find the SLRP4. It's just $199 for a powerful Raspberry Pi 4 device. It's industrial ready, it's UL listed, a very reliable, rugged device. You can use this as an edge device, you can use this to collect data, you can use this as a PLC. It comes with OpenPLC runtime pre-installed in it, very easy to use. So just go ahead and get yours while we have it in stock. Thank you so much for watching, and I see you guys next time.